So I'm going to talk about the Crossplane project. My name is Jared Watts. I'm a senior maintainer on this project, and I'm also one of the founding engineers at Upbound. So let's get into it. So Crossplane is a brand new open source project. Literally on Tuesday of this week, we just made it public and just open sourced it. So it hasn't even been on GitHub for a week yet. But what it is it's an open source multi-cloud control plane. So that means it spans across different cloud providers, different regions, even on premises, and it's based on Kubernetes, so it uses the same declarative management style API that you're used to with Kubernetes already. So you can tell it, declare what you want it to do, not how to do it, and it takes care of it for you with smart controllers that can model and manage resources and infrastructure in cloud providers and on premises as well. And what this does is this enables workload portability and reusability across all environments. We're going to get into that more in a bit here. And it's also got a really smart scheduler to dynamically choose the best fit for where your workload should go. You're dealing with all these different clouds. Where should the workload go? The scheduler can figure that out for you. It also has a separation of concerns between developers and administrators to kind of get you to focus on just your application, or not worry about the specific details in your environment if you're a developer. And it's, I mentioned it's open source, it's community driven, it's extensible, so we're going to start growing this community on this project. So first of all, why multi-cloud? We talked about this a little bit, and for me, it comes down to the power of choice. For your application, you want to be able to choose the best place for it to run every single time. There's a bunch of different parameters you might want to choose on, cost, functionality, compliance, all sorts of things, but multi-cloud's good because you get to choose the right place for your workloads to run. Talking about the declarative API, we believe in its a convergence on the Kubernetes API. So what that allows us to do is native integration with kube control, as well as other tools and libraries and user interfaces out there that manage interact or interface with the Kubernetes API. There's a super rich ecosystem and community out there that's been growing around Kubernetes. Or this KubeCon, I think, has 10,000 people or so. So this community is getting huge, and Kubernetes is really showing itself as a powerhouse of container orchestrators. There's a lot of lessons we think that were learned from container orchestration that we can start applying to multi-cloud workloads and resources as well. So when we talk about resource management, so Crossplane has a set of custom resources, and what those do, they model different cloud provider resources as well as some of their infrastructure as well. So for instance, in Amazon RDS database, there's a custom resource that models that for you. There's also custom controllers that run, say you create an instance of that RDS database with kube control. That custom controller will pick that up and use the Amazon API to make that RDS database come up for you on demand. And the good thing about this is it's not just run once and and the controllers stop at the initial deployment. It's active reconciliation. So as things go wrong, or health monitoring, or day 2 operation stuff, these controllers and these operators will do that over time for you actively. So here's a little picture of what it looks like. So basically, the middle is a very important part, that it's, all the Kubernetes API machinery is there. We got the scheduler in the top right. We have our resource controllers and some third-party resource controllers as well that all build on that Kubernetes API machinery. And since it's using the Kubernetes API, that allows us to use kube control, other libraries, UI, and such on the left side to interface with it. And then on the right side, we have all the different cloud providers, Amazon, Azure, Google Cloud, and some third-party independent cloud offerings as well that these controllers manage for you. So this is a really good part here is this allows portability. So these, instead of just modeling specific cloud provider resources, there's also these abstractions on top of that. We talked about this earlier in one of the other talks, but things like databases and buckets and clusters, Kubernetes did a great job at abstracting a volume for you, but let's take that further. Let's model other things so that your workload that uses things that aren't just volumes can start being just as portable as pods and volumes are. And so we want you to be able to write once your application and its resources, and then be able to run that anywhere. Any cloud, on premises, doesn't matter. 30 seconds. So separation of concerns allows the developer to just worry about their application and not worry about the details. Let the administrator deal with that. This is similar to storage classes and persistent volume claims for a concept of resource classes and resource claims for all sorts of things, buckets, message queues, databases, everything. And also the scheduler, the purpose of that is to be able to optimize for the right place to run your workload for the right parameters, policies and cost and compliance, availability, features, all that sort of stuff. Scheduler will figure out where it's going to go for you. And there's ways to get involved. We're on GitHub at crossplane.io. And tomorrow, go see this talk. It'll be a live demo of Crossplane running across all the major cloud providers at the same time in Ballroom 6B. Thank you.